This is Year 11 Chemistry, Nomenclature Rules. Rule number 1, naming binary ionic compounds made up of metals plus nonmetals. Metals with the ending IUM will remain as IUM for a binary ionic compound. Nonmetals with the ending INE will transform into IDE for a binary ionic compound. For example, metal will always stay as IUM, whether it is an element or the ionic metal, such as aluminium bromide. Bromide is from bromine. Aluminium iodide. Iodide is from iodine. Aluminium chloride. Chloride is from chlorine. Aluminium fluoride. Fluoride is from fluorine. Exceptions to the rule: when the nonmetal ends with on, gen, gen, us, us, or ur, the ion of its root element still ends with IDE. For example, aluminium carbide is from carbon. Aluminium nitride is from nitrogen. Aluminium oxide is from oxygen. Aluminium phosphide is from phosphorus. Aluminium sulfide is from sulfur. Aluminium hydride is from hydrogen. In this case, hydride has a valence number of -1. The metal in the binary ionic compound is represented by the positive ion, cation, and the suffix IUM does not change from its root element. The nonmetal in the binary ionic compound is represented by the negative ion, anion, and the suffix changes from INE or ONGENUS or UR to IDE from its root element. Rule 2. Naming metals with one or more positive charges, also known as valence number or valence charges. Most metals have a single valence number while others may have several valence numbers. If the latter condition is true, then the following naming protocols would apply. Using the common name, the charges of the respective metal ion is differentiated by the ending of OUS and IC. Metal ions ending with OUS will always be the lowest valence number. Metal ions ending with IC will always be the higher valence number. Using the systematic name, the charges of the respective metal ion is differentiated by the value of the Roman numeral in the parentheses. For example, copper plus, the common name ion is cuprous. Systematic name is copper 1. Copper 2 plus, cupric. Copper 2. Fe plus 2, ferrous, iron 2. Fe plus 3, ferric, iron 3. Cr plus 2, chromous, chromium 2. Cr plus 3, chromic, chromium 3. Rule 3. Naming polyatomic ions. Polyatomic ions are charged molecules that are commonly made up of a grouping of nonmetals, such as hydrogen, carbon, nitrogen, oxygen, and sulfur. Polyatomic ions can also be made up with certain metal ions, together with the common groupings of nonmetals. There are 2 cationic polyatomic ions, and the rest are anionic, negatively charged. Polyatomic ions with varying numbers of O atoms are named with specific prefix, root, suffix formats. The number of oxygen atoms in a polyatomic ion grouping can vary from 1 to 4. Using the prefix, root, suffix format, a polyatomic ion with 1 oxygen atom is hyporootite. A polyatomic ion with 2 oxygen atoms is rootite. A polyatomic ion with 3 oxygen atoms is rootate. A polyatomic ion with 4 oxygen atoms is perrootate. When a polyatomic ion is paired up with an appropriate number of hydrogen ions, then it becomes a neutrally charged acid. Sometimes the suffix name of the acid is dependent upon the suffix name of the polyatomic ion in regards to its number of oxygen atoms. For example, hyporooteite goes to hyporooteous acid, 1 oxygen atom. Rooteite goes to rooteous acid, 2 oxygen atoms. Rooteate goes to rootic acid, 3 oxygen atoms. Perrootate goes to perrootic acid, 4 oxygen atoms. Exceptions to the rule: when cyanide ion is paired up with a hydrogen ion, it becomes an ic acid. The suffix of chromate and dichromate both ends with ate, although the number of oxygen atoms are different. Ammonia is ammonium, water is hydronium, water negative ion is hydroxide ion, cyanide is hydrocyanic acid, nitrite NO2-, nitrate NO3-, from nitrite to nitrous acid, from nitrate to nitric acid. Carbonate, hydrogen carbonate, carbonic acid. Sulfite, hydrogen sulfite, sulfate, hydrogen sulfate. From sulfite, one can make sulfurous acid. From sulfate, one can make sulfuric acid. Phosphite, hydrogen phosphite, dihydrogen phosphite, phosphate, hydrogen phosphate, dihydrogen phosphate. You can make phosphorus acid from phosphite. You can make phosphoric acid from phosphate. Hypochlorite, ClO-, chlorite, ClO2-, chlorate, ClO3-, perchlorate ion, ClO4-. Similarly, if you were to put hydrogen in front of these hypochlorite, chlorite, chlorate, and perchlorate, you will get hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. Similarly, you can have the bromine part of things. Hypobromite, Bro-, bromite, Bro2-, bromate, Bro3-, perbromate, Bro4-. In acidic form, they are hypobromous acid, bromous acid, bromic acid, perbromic acid. Hypoiodite ion, IO-, iodite, IO2-, iodate, IO3-, periodate ion, IO4-. This can lead to hypoiodous acid, HIO, iodous acid, HIO2, iodic acid, HIO3, and periodic acid, HIO4. We can have manganate, MnO4-, hydrogen added, becomes permanganate acid. Chromate, CrO42-, dichromate, Cr2O72-, becomes chromic acid or dichromic acid. Rule 4. Naming binary ionic compounds made up of metals plus polyatomic ions. Metals ending remain the same with IUM. Polyatomic ions are named according to Rule 3. For example, aluminium hydroxide, aluminium nitrate, aluminium sulfate, iron 2 sulfate, sodium hypochlorite. Rule 5. Prefixes for molecular compounds. Number of units: mono 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. For example, phosphorus pentoxide, carbon monoxide, carbon dioxide, and carbon tetrachloride. Thank you for watching. Please subscribe and follow this channel for more quality contents. I'll see you next time.